I'm Nick Hnatiw, the CTO at SideChannel. We really are trying to focus on, three key aspects to securing your network. And really today I'm going to focus on how, we compare to VPNs and how you can replace your VPN entirely with Enclave. So as I said, Enclave has a number of different major features, major functions. We call them modules. I'm going to be focusing in on just our networking module today. So networking allows us to create custom connections to any other machine on your network, whether that's cloud, whether that's on-prem. It doesn't matter to us whether it's a third-party access that either you're managing a third party or a third party is managing your access. Enclave can support all of these features, all these use cases, and provide you granular port level control access to any resource in your environment. That will allow you to, both connect users as well as devices to those systems. We do this with an agent-based software-defined technology. We call it Enclave, and what we're able to do is build out microsegments inside of your environment that can where rules are allowed to be created between machines. So you could think of an enclave as a pool of resources and a pool of users that can potentially have connectivity. And then inside of each enclave, you're able to establish that connectivity, to grant that permission. So just because these machines are sort of in this enclave doesn't mean they have access to one another. They only have access once I draw a rule between those two. And so in this particular case, we've established an SSH rule from these users to these systems. Likewise, I could establish a web rule, right? I can give them HTTP access. It would create port 80 in that same list. You can see our rule number go up to 2 here, and now we've got our 2 rules. Just as simply, I can delete that rule, and that goes away. Now you're back down to just SSH access for these users. So rule generation is very simple. It's very intuitive inside of the platform. We utilize groups for both machines and users to batch rule creation. So you don't have to drag, John to each of these. You don't have to drag Don to each of these or Nick to each of these. You can just grab one group to the next group, and now you've got that access inside of there. This allows us a couple of major pieces here. So one is, as I just mentioned, it really simplifies rule creation. We can establish what groups inside of our organization can access which resources very simply. The other major component of this is connecting this to an IAMS. So whatever identity access management system that you might be using, we can connect to that and pull in the users, pull in all of those groups, and dynamically adjust those groups as the IAMS gets updated. So you no longer have to do identity management inside of our platform. You can do identity management wherever it is that you're doing it. Will get updated as those changes are made, and pull people out of groups, which would then remove their access, or add people into groups, which would grant them access. That will happen dynamically as you change your IAMs. There's no alterations you have to do in the system. So a really nice kind of feature to kind of play in the zero trust model, and really kind of relying on identity to be able to guide access control, which is really one of the core tenets of zero trust and what we're trying to adhere to here with Enclave. So how does this play with sort of in the VPN replacement realm? So as we know, VPNs, right, they allow us to access company resources. The way that they're typically set up is you enter into sort of the VPN IP pool, and then that IP pool is granted to the rest of the network. As you can understand, or maybe if you don't understand, that exposes you to potential attack vectors. So if somebody is compromised coming into the VPN, well, now that compromised system has access to the rest of the network. We don't want to follow that model. We want to follow the zero trust model, where we can say, just because this person has access doesn't mean they have access to the rest of the systems on our network. And we'll go back to the dashboard here and see. So there's a number of systems on here, but these 2 users, Don and Nick, only have access to these 3 control servers with that SSH port in that one system we saw there. Whereas John has access to a couple of other systems, But what we're really trying to do is bifurcate who can access, who can physically send network packets to which machine. And this is something that just VPNs don't do right now. And to configure them to do this is a little bit more complicated. It's not impossible, but complexity and personnel experience the required personnel experience goes up considerably. So we're really trying to limit that, make this very simple and accessible to people to be able to not only have secure remote access, but to enable zero trust methodologies to govern how that access is granted. So no longer are we giving you access to the entire network. We're really just giving you access to the resources you need in order to do your job. That's really the core aspects of how we do how we do secure connectivity. Now, the aspect of remote connectivity doesn't change for us. And this is one of the core principles and why I really get behind the software-defined networking technology for microsegmentation or VPN replacement or ZTNA or any of the other, many of the other names that are used for this technology. What software-defined networking allows us to do is to create a single rule set. And now it no longer matters where these people or these machines exist. So if a machine moves from one rack to another rack or from one data center to another data center, as long as the agent is still configured the way that it was, you will be able to connect to that system. Likewise with people, if they're in the office, if they're out of the office at home, or if they're at a cafe, at the airport, wherever, the software-defined node will verify who they are first, and then allow them access to the resource they have access to. And that is the power of the technology here. It no longer matters where you're coming from or where you're trying to reach, where you exist to try to get your access. As long as you have permission to access that resource, you'll be able to. And that's really the core power here. With this system, we have a handful of different types of elements inside of here. So we already talked about enclaves, and those are the sort of the borders that we draw around different elements that we want to relate in our system. We have also, our agent comes in two flavors, so a node and a user. So you can think of nodes, we really think of these as connection types. So a node to node connection type would be like a permanent connection. You can see that here in the top of our network map, and that's really those server to server communications that need to always be up and always be connected. So that's how we define a sort of node to node connection. And then we have user to node connections. So user to node connections would be those connections that are more ephemeral, right? It's a person, they're accessing a resource for a given amount of time, and then that connection is going to get destroyed. So a user to node connection are those ones where we're looking at them as being more ephemeral, right? They're going to go in, they're going to access that resource, and then that connection is going to get torn down. And that's really the key differentiator between there. We'll also add in a couple of other checks, right? We can do MFA checks on people and verify that they are who they are. We're also, as I'd mentioned before, going into the IAM system and getting the verification from the IAM system that they are indeed the identity that they are claiming to be.